Professor Schürer is in history at the University of Leicester, and he's a fellow of the Royal Statistical Society, a fellow of the Academy for Social Sciences, and a senior member of the Wolfson College and a visiting scholar at Cambridge. He was formerly director of the UK Data Archive and a member of the Cambridge Group for the History of Population and Social Structure, research director and director of the Centre for Local and Regional History, and lecturer at the Department of History in the University of Essex. So Professor Schürer is most well known for his genealogical research to find the descendants of the immediate relatives of King Richard III of England, whose remains were found in a Leicester Car Park in 2012. Professor Schürer's research was instrumental in identifying the remains of that king, who was killed in 1485 at the Battle of Bosworth Field. And that's what we're going to be hearing about today. And if, like me, you're a fan of the Chronicles of St. Mary's, that's in What Can Go Wrong. Now, over to Professor Schürer.
Okay, thank you very much, Martine. Hopefully you won't be able to see me, but hopefully what you should be able to do is see a title slide. The title of my presentation tonight is How Forensic Statistics Nailed the Identity of the Last Plantagenet. Obviously, I hope that there'll be time for questions at the end. And I've got multiple screens here, which unfortunately you can't see, and doesn't really matter, but it means that I'm going to have to juggle between them. There might be sometimes a bit of a time delay at moving from slides, so I apologize about that in advance. But let's move on. I should imagine that virtually all of you have heard about the discovery of Richard III, the king in the car park, as he's become known. And I'm going to tell perhaps a slightly different version of that story, which is more focused on identification, as we will see, rather than discovery. But before I do that, the first thing I want to do is to acknowledge that what I'm talking about today is the product of the work of many people. The wonderful thing about working on this project is that one was part of a team of people who shared expertise and brought to the project a whole range of different skills and expertise. And I was just lucky to be there in the right place at the right time. And the first person to acknowledge is Philippa Langley, and you can see her there, hopefully on your screens. Philippa is not a member of the University of Leicester. She's a freelance scriptwriter, actually, and it was her passion, if probably obsession is probably a better word, for Richard III that made the whole thing happen. And it's really important to acknowledge Philippa's role, because if Philippa hadn't harangued, and I don't mean that in an unpleasant way, but harangued the city council to allow the dig to happen, then the discovery would never have been made. She very much initiated the whole project. The archaeologists, I'm not going to really be talking much about the archaeology. I'm not an archaeologist, although I have worked very closely with both Richard Buckley, who you can see there, and Matt Morris. Richard's the one holding a bit of stone remains from the old priory, and Matt's the one in the trench in the hat. And Matthew actually was the one that first found one of the bones that later we knew belonged to Richard III. Also, and again, it just shows that this is a multidisciplinary team, cross-disciplinary team. There's Jo Appleby, who is a member of the archaeology department, but she's an osteologist. She's the bone specialist. And she in particular did a lot of work on the spinal abnormality, the scoliosis of Richard III that we'll see later, as well as the various wounds on the skeleton. Sarah Hainsworth, who's actually no longer at Leicester, she's moved across to Aston University. She's actually an engineer. She's in the engineering department, or was at Leicester, and is now at Leicester, Ashton. She worked particularly on the wounds. She's actually a wound specialist, looking at knife wounds and stab wounds in particular. She's the sort of lady that is evidence at trials where somebody's been stabbed, but here she was giving evidence around the stabbings relating to Richard III. Mark Thomas and David Bording, they're not at Leicester either. They're in London, and they're kind of forensic statisticians, you might say, and they provided assistance to the project. And last but certainly not least, my dear friend Peri King, who, although she originally did some training in archaeology, is working now in the genetics department and did a PhD in the genetics department with Alec Jeffreys of DNA fame. And she and I worked on the DNA side of all of this that we'll come to later on. So realistically, without all of that lot, none of this would have happened. My contribution in some respects was possibly quite minor in compared to some of theirs. So the story of the discovery of Richard III has been told several times. You will have heard it at the time, you would have seen programs, you would have read newspaper reports. We worked out, or the University of Leicester worked out, that something like 1/4 of the world's population heard about the discovery of Richard III at the time, which is quite amazing for an academic piece of research. However, what I'm going to talk today is about the identification, and I want to make a difference between the two. A lot of people sort of say, the archaeologists discovered Richard, the archaeologists discovered Richard III. No, what was discovered were some bones, which we happen to call skeleton 1. These were then later identified to be those of Richard III. The point I'm trying to make is that discovery and identification are two very separate processes. And the other misunderstanding about the identification is that, again, the common myth, if you like, that's grown up is that, well, it was all about the DNA. You know, DNA proved that it was Richard III. Well, again, as we will see, and hopefully you'll appreciate this by the end of my talk, it's really not quite that simple. DNA was a very important key, but it wasn't the only factor in the identification process. The whole thing is just simply not as simple as that. But let's start with looking at the chances of finding Richard. Well, at the beginning of the project, if you ask the archaeologists, they will put their hand up and say, actually, the chances, we thought that the chances of finding Richard were very slim. And actually, at the beginning of the project, they identified 5 objectives or aims, if you like. The first of which was to find the Franciscan friary buildings in which we knew Richard to be buried. Within that, to work out which bits are which, where the church is, where the cloister is, and so on, and hopefully locate the church within the friary fabric. And then maybe to identify which is the east end of the church and where the choir is. And then possibly, if you've identified the choir, which is where we know Richard to have been buried, locate the mortal remains of Richard III. So those were the kind of objectives of the dig in that order. And in fact, in terms of the chances of being successful, they kind of had a reasonable expectation around 1 and 2 that they would actually identify the friary and something to do with the layout and structure of the friary. But there was really only an outside chance of ever really working out where the choir was, and virtually the notion of finding Richard was not realistically ever considered. If you ask Richard Buckley, who led the dig, he will tell you that the reason he agreed to do it was not actually to discover Richard, but as an archaeologist who's dug in Leicester and is particularly interested in medieval structure, medieval Leicester, he kind of said, well, this is a chance to actually discover more about one of the most important, well, an important building in medieval Leicester, of which very little is known. He didn't think that there was any realistic chance of finding Richard at all. And just before we perhaps move on, I think it's important to say that did we know that Leicester was in the car park? Well, the simple answer is, well, yes, in a way. It was known for a long time that he had been buried in the choir in the Church of Greyfriars, and indeed there were even, you can see here, a Daily Telegraph article back in 1993 that talks about how Richard's body was lying probably in the famous car park. So the car park itself was not a revelation. What mattered is that the city council, who owned the area, gave permission for the first time for this to be opened up. Now, I don't know if any of you know Leicester at all, but here is one of the first detailed maps of Leicester. This is the map by Thomas Roberts of 1741. And again, if you do know Leicester, you might be a little bit confused about the orientation of this map. Again, I don't know if you can see me moving my cursor around, but you'll see that north is actually in the top right-hand corner, not at the top of the map. And you'll see again, I don't know if you can see me moving the cursor, but the Greyfriars Priory is very clearly indicated here on this map. Of course, the priory was not in existence by then. It had been sold off as a result of the dissolution of the monasteries and entered into private hands long before this map was printed. And of course, there are no physical remains of the priory today, and certainly there were none even by the 16th century. So that's the whole point, is that the location where he was buried had been completely lost. But if we blow up this map, here is the area, and if we orientate it so that north is now at the top rather than off to the side, and what we can actually do is overlay this. Here is a modern Ordnance Survey map, and we've obviously changed these images so that they are of a similar scale, and we can indeed overlay them. And you can see that actually there's a very good match between the mid-18th century map, the first detailed map of Leicester, which exactly locates the position of the Greyfriars. Now, what you've got there in the dark blue lines is that you can see that today much of this area is heavily built upon. And the open areas are the ones within the blue spaces. And the area where it actually says Greyfriars is where this famous car park is, the social services car park. There is another area over here, again, I don't know if you can see my cursor moving, that actually is the old playground to a school that is here, not part of the car park per se. Now, sorry, I'm just not quite sure what's happened here. Why have we not? Yeah. So the important point to realize is that only 17% of the original friary grounds were not built upon. So first of all, and this is explaining why the archaeologists thought that there was a very limited chance of being able to find Richard. A, because they only had 17% of the original grounds to work on. And given that the time, resource and money that was available for the dig, the council, this is a working car park, you have to remember, it certainly was at the time. And so the council during the summer said, you have 2 weeks in August to do the dig.
Wow.
That's 2 weeks from beginning to end. That's 2 weeks to put the first digger in the ground, and you have to return it as a working car park 2 weeks later, tarmacked over, ready to park cars on again. So very limited time and very limited space. Essentially, it meant that only 1% or less of the formal area of the friary could be used for excavation. So in a sense, it is indeed like looking at needles in haystacks.
No, nothing.
No, it's his spell checker.
However, despite this, it was only on the first day of the dig that the skeleton that eventually was proven or shown to be that of Richard III was found in Trench 1 on the very first day of the dig. Although, of course, when it was discovered, we didn't actually know it was Richard. It was only as a result of subsequent archaeological work we realized it was in the right place. We knew from historical sources that Richard was buried in the choir of the Church of the Friary, as I have mentioned before. And here he is. This is a picture of him before his skeleton was essentially exhumed. And the skeleton, you can see, is roughly in fairly good order. It's intact, as you can see, apart from the fact that there are no feet. A lot of people have asked, well, was his feet chopped off before he was buried? No. The simple answer is that the feet were removed by subsequent disturbance of the site. To cut this long story short, probably the Victorians cut a trench for a building that's no longer there, but went straight through his feet. You can tell that the feet were severed off post-mortem. They were clearly not severed off peri-mortem, i.e. close to death, because you can tell by the way the bone has broken. So there he is. What you can also see is that there is a clear curvature of the spine that we'll talk about later on. I don't know if you can see my cursor moving, but there is a clear curvature of the spine. What you can also see is that the grave is too short. You see how the body is crunched up here with the head. It is not laying out flat, which suggests that this was a grave that was dug in a hurry. It's actually quite a shallow grave. They dug it too short, and they obviously laid his feet in first and realized that there wasn't quite enough room, and that's why the head is rather scrunched up here. The other thing to note about the skeleton is that the hands are odd, in that you can see that the arm here is over to the right hand side. So the left arm is coming over to the right hand side. And although we can't prove it one way or the other, because there are no remains that would allow us to do it, it would suggest that when he was put into the grave, the hands were tied. Otherwise, the left arm would have lain rather differently from the way it is. Traditionally, people are buried in this period either with their arms straight down the side of them, or possibly actually crossed over their chest, kind of crossing their heart, so to speak. This is neither. It's a very unusual. Richard Butley, who has excavated hundreds of medieval graves in Leicester, has said he's never seen a medieval burial like this, which suggests that there is something quite unusual about it. Here he is, all cleaned up and all tidied up, laid out back in the lab. You can see here, much more clearly than the previous slide, the curvature of the spine due to scoliosis, and we'll talk about that later on. And you can clearly see how the feet have been severed off. But here he is, all of his ham bones and what have you, all his rib bones. So it's actually a fairly intact skeleton. You can see that the jaw has become separated, and there are other little bits that have come off, but otherwise it's a fairly intact skeleton, which is good. Again, and the important thing is that once we got the skeleton out and started looking at it, it showed some important features that are relevant to the statistical analysis that I'll be talking about later on. It also showed signs that there were clearly fatal injuries that were consistent with having died at the result of armed combat. This is not somebody who had just fallen down a flight of stairs or clearly died of natural causes. And obviously there was marked scoliosis, and we'll come on to those things later on. But first of all, let's have a look at the skull. Here is the skull. And you can see that there's a lot of trauma to the skull. All of these areas that I've marked here, 6 of them, and there's a 7th as well. These are to do with essentially battle scars. You've got a number of wounds to the top of the head, where literally chunks of the skull have been sliced off. And at the front, you can see that there are dagger marks, if you like, to the front of the face as well, including one to the right at the nose that would have gone in into the face, into the kind of like upper mouth area, if you like. One's around the jaw, which suggests that he was possibly at one stage wearing a helmet, which was cut off, sliced away from the leather strap. And in fact, the ones at the top of the skull that you can see, there's no way that those could have been carried out unless the helmet would have been removed. So this is somebody who's come off a horse, my kingdom for a horse, and is essentially being attacked on the ground. None of these are, however, likely to have caused death. They would have been very unpleasant, but none of them would have caused death. What's interesting is that you can see, and this is work that Sarah, my friend and colleague Sarah Hainsworth did, we can see that 2 of those wounds were actually done by exactly the same blade. Because of the striations on the blade, you can see that they were done by exactly the same instrument. if we look first on the left-hand side, you'll see, and again, hopefully you can see my cursor moving around, there's a depression at the very top of the skull. You can see it. This is an X-ray taken through the skull where it's pushing the bone in. And this is a result of a very short bladed instrument with something called a roundel being forced down on the top of the head with a lot of might. Again, it didn't penetrate the skull, would not have killed him, but it certainly would have been very, very painful. However, if we look at on the right-hand side down here, looking at the base of the skull upwards, you'll see that there's a big piece of bone here that's missing and another one of here that's missing. Neither of those are good. And they are caused by, again, a bladed instrument being yielded, probably not a sword, probably more of a halberd to give it the sheer velocity, if you like. And that essentially whacked off a bottom bit of Richard's skull. That would have exposed the brain and would have made death fairly imminent, if not immediate. And there's another insertion into the skull here, which is caused probably by a rapier sword going through the skull, through the brain, and actually hitting the skull on the inside on the other side. So not pleasant, and a very nasty death. Scoliosis, you probably have heard about the spinal abnormality. What you have there are two vertebrae, and what they show you is that this is a very unhealthy spine. In a healthy spine, your vertebrae tend to be like butterfly shaped. They tend to be symmetrical. You can see that these are far from symmetrical. And if we start this going again, you can see in the 3D image, not sure why it's not working. Go on. There we go. Oh, well, never mind. Anyway, you can see that the spine is indeed severely curved as a result of idiopathic scoliosis. Idiopathic means exactly kind of what it says. It's specific to the individual. A lot of people think that this may be congenital. It's not. It's not. Richard III's scoliosis was not inherited. Like most scoliosis, it came on during the age of adolescence. He wasn't born with it. Came on around about the age of 12 or 13 and gradually got progressively worse as he got older. Now, sorry, again, just trying to move on to the next slide. So now on to the statistics at last. And let's start with this chap. This is Thomas Bayes, who, as you can see, lived in the first half of the 18th century. Thomas Bayes was very much a kind of polymath in a way. He was not only a statistician, which is primarily what he's known for or remembered for today. He wrote philosophical tracts, and he was, of course, a Presbyterian minister as well. But he's also, of course, the father of Bayes' theorem. And why is this important to Richard III? Because the identification very much relied on Bayesian statistics in order to put all of the parameters into an equation and work out the importance of them. Now, I'm not going to talk at any great length about what Bayesian statistics is, but primarily it's essentially about inferring the probability of something to be either true or false, right or wrong, and how that probability changes the more information you throw at it. So let me give you an example relevant to the current day. Let's say that tonight a Martian, theoretical Martian, landed in the center of Birmingham. What they might judge from this is that people never go into the center of Birmingham at night. They all stay in their homes and they never come out because they're afraid of the dark and they're afraid of one another. They all hide away from one another. The point is that they are making an assumption based on the only information that they have, which is the city centre is deserted. Let's say that then suddenly somebody does come into the city centre. Let's say that it's a young teenage woman. If that's the only human that they know, they might assume that all other humans are like that young teenage woman. They might assume that humans are on average 5 feet tall, dressed in a certain way, etc. The point is that the more that they are exposed to human society, the more they have evidence to build up a picture of human society. And that's kind of the basis of Bayesian statistics. It's about inferring the probability about something. What's the probability of humans being 5 foot tall? Well, if you only ever measure one person and they're 5 foot, the probability is very high. If you measure 100 people of varied height, the probability obviously changes. Yeah. So it's based on the amount of information and the type of information you throw at it. So what we found in Trench 1 was a skeleton. And essentially, this is what we were looking for. We know that Richard was buried in 1485, and we know where he was buried in the choir of Greyfriars. So we know when and we know where. So we also know his age at the time of death. And we probably should expect there to be battle injuries. We know that he died in the battle, and we know that he died in the thick of the battle. So we should expect to see certainly a skeleton that's not died of natural causes. Then, of course, there's the possibility of the Shakespearean hunchback. Well, Shakespeare talked about him as being slight-built, hunchbacked, and also with a withered arm. Yet, can we really rely on Shakespeare? If we turn instead to contemporary sources, people who actually would have seen and potentially have met Richard, John Rouse, for example, who was a chronicler and a priest at the time, he said that Richard was small in stature, with a short face and unequal shoulders, the right higher and the left lower. Nicholas von Poplar, who was visiting from Silesia at the time, he says, Richard is a high-born prince, 3 fingers taller than I, but a little slimmer and not as thick set as I, and much more lightly built. He has quite slender arms and thighs, and also a great heart. And that would have been extremely useful had we actually known how tall and how slim or otherwise Nicholas van Popper is. But unfortunately, we don't. But we know that Richard was 3 fingers taller than him. But what's interesting there is he talks about the slender arms and thighs. And it's interesting to note that if we, I'm not going to try and go back, we can look at it later on, but if you remember the skeleton that was laid out in the lab once it was cleaned up, Joe, who cleaned it up, I remember before we did any DNA work, was particularly concerned. She said, I think this could be a girl. I've never seen anybody with such slender bones and such slender fingers. And Joe actually was worried that the skeleton might be female, given this, how slender some of the bones were. So this is actually a very slender skeleton, and it fits in with that description. But also notice Rouse's description, unequal shoulders, the right higher and the left lower. No mention of a hunchback, but not standing straight, which is exactly what you would expect with someone with quite severe scoliosis. It's not a hunchback, but the shoulders will not be even, because essentially because the spine is twisted, they're pulling one of the shoulders down, okay? So that description by Rouse is entirely in keeping with somebody with scoliosis. So let's start looking at the scientific evidence. Well, he was found in the appropriate place. The skeleton clearly is a male and of approximately the right age. He clearly has significant battle type injuries, and he has a spinal abnormality, which would account for the contemporary, ignore Shakespeare, the contemporary descriptions of Richard III. Radiocarbon dating places the burial also within an acceptable range, i.e. Around 1485. You can't be precise with radiocarbon dating, but it's certainly not, you know, whatever, 100 years before or 100 years after. It's within an acceptable range. And we'll come on to this later on. There was a match between two mitochondrial DNA and two who were distant relatives. Now, however, there was a non-match between the Y chromosome DNA and other distant relatives. So actually, the DNA evidence is inconclusive. The mitochondrial DNA, which is the DNA that is passed from mother to daughter, well, it's passed from the mother to all of their children. So we all have our mother's mitochondrial DNA, but only women, only daughters can pass it on to a subsequent generation. So Richard had his mother's, Cecily Neville's DNA. Of course, he shared that with all of his siblings. They will all have the same mitochondrial DNA, but only his sister, Anne of York, can pass it on to subsequent generations. So what we did was to trace present-day descendants through Richard's sister, who will have inherited that mitochondrial DNA, and that matched well. The DNA, the Y chromosome, what you might call the male DNA, however, did not match male, not descendants, because Richard had no descendants. He had well, he had a son, but he died before he died before Richard himself. He also had some illegitimate children, but none of them had sons of their own. So in order to trace the Y chromosome, you actually have to go all the way up to Edward III and then back down again through John of Gaunt and John of Gaunt's illegitimate children, the Beaufords, down to the present day. And that doesn't match, and we'll come on to that later on. So let's move towards the hypotheses. And I'm just trying to keep an eye on the time. I'll speed up a little bit. So what we're doing is that we took a very conservative approach, and we essentially had two opposing hypotheses. Hypothesis one is straightforward. The skeleton one is Richard III, and the hypothesis two, skeleton one is not Richard III. And essentially what we're doing is looking at the available data that affect those different hypotheses. And you have to obviously make sure that they are independent of one another. A lot of information here, and you can read these perhaps on the slides later on. I don't really want to go into it, but this is looking at the joint likelihood. So essentially what you're doing is constructing likelihood ratios for each piece of evidence, and then you're adding those together. What's important is the last bullet here, is that you have to make a difference within this particular type of calculation between background information and foreground information. And because of that, we estimated that there's a prior probability of it being less than 40, 1 in 40. Again, I don't want to go into the details of that now. I'm happy to try and answer questions about it later on because I'm running out of time. But you can look this up later, and you can go to the paper if you want, where all of the details are given there. But what I wanted to do is run through the evidence that we used and how that was used in the statistical analysis. There's also, of course, a problem of small numbers. And there's a technical note here about the way in which we dealt with those. Those were dealt with in the usual statistical way. And again, I don't want to dwell on that here, but you can go back and look at the slides in greater detail if you are particularly interested in that aspect. First of all, the radiocarbon data, and they were obtained from 2 samples from the rib. You have to, first of all, realize that the priory existed only within a certain period, from around about 1225, 1230 to the dissolution of the monasteries in 1538. And what that actually does is that it gives us a 95% confidence interval on the date ranges that I've mentioned before, i.e. within the scope of when you would expect this burial to take place shortly after the Battle of Bosworth. And what you have to realize is that in order to do this, you have to look at Richard's lifetime itself, because the radiocarbon distribution will fall over his lifetime, and so you have to divide that by his lifetime, and therefore what we actually get is that you have limited support for hypothesis 1, i.e. this is the skeleton of Richard III. So if you just took the radiocarbon data alone, essentially what I'm trying to say here is that the radiocarbon data provides limited support for hypothesis 1. It's not conclusive. So then let's layer in more information, like to do with the age and sex of the skeleton. We know that that we have a male that's aged between 30 and 31, and under hypothesis 1, again, you get an estimate of 0.95. But what you've got to do is ask yourself is, what's the likelihood of finding a skeleton of this age and this sex in a site like this? All right. So what you have to do is compare. So let's say this was just a random skeleton that we had dug up. What's the chances of finding randomly a skeleton which is male, aged between 30 and 34? And so what we're doing here is comparing it to other archaeological sites, because what we need to know is not how many skeletons you're going to find, but how many skeletons of the right age. And looking at evidence from other sites, we've got information on 706 skeletons where there's a clear age and sex assignment. 127 were male in those ages. So you can work out the probability of finding a male skeleton of the right age. And essentially what that means is, again, there's limited evidence based on age and sex of this being Richard III. So adding those things together, so none of this as yet is in itself conclusive. It's pointing in the direction of it being potentially Richard III, but using this information alone, this is not conclusive evidence. Now let's look at the presence of scoliosis. Well, this is where the data begins to get a bit difficult. Looking at the data from Robertson Cox Health and Disease in Britain, which has looked at over 1,000 skeletons, 5 of them have scoliosis. So a relatively small number. So the probability of finding a skeleton with scoliosis is much slimmer. There's a slight problem with this, however, because a similar deformity is not just caused by scoliosis. There are other ways in which you could get a physical condition like the one on the skeleton 1, including Ebb's palsy and Spindler's deformity. So you have to take those into account. Luckily, they are both very rare indeed. Ebb's palsy, in case you've heard of it before, that's what Kaiser Wilhelm actually had. His withered hand was a result of Ebb's palsy, as a result of a childbirth deformity. So again, if you put all of this into the mix, if you put all of this into the mix,
hello, puppies.
Someone's got their microphone switched on. If they could maybe switch it off, that would be useful. So if we put all of this into the mix, again, what it shows is that there's now moderately strong evidence. The fact that we have a skeleton with scoliosis means that this is actually now bringing up relatively strong evidence that this is indeed Richard III. So moving on now to the perimortal wounds, wounds that were created at death or close to the time of death. As we've seen, there are multiple wounds around the skull, as well as 2 on the bottom of the cranial skeleton. And these wounds are consistent with what we know about Richard's end and subsequent treatment. However, we have to assume that there is an exaggeration about Richard's death in the historic accounts. Don't forget, we were trying to be incredibly conservative. But then we have to ask ourselves, well, what other skeletons in priories have similar types of wounds? Again, a bit like looking for males in their early 30s. And so we looked at similar evidence across 8 other friaries. You've got them listed there. And what that actually showed was that when you actually look at this, and what's the other important thing to consider is where he is buried. He's buried in the choir, which is a very prestigious place to be buried, and therefore, in that sense, may rather different from other archaeological sites. But when you put all of that together, it shows, again, there's moderately strong support for him being Richard I, hypothesis 1 being true. So none of this so far is proving categorically it's Richard. It's pointing to strong to moderately strong support. So now let's come on to the Y chromosome data. As I said, this didn't actually match. The Y chromosome didn't match that of Henry Somerset, the 5th Duke of Beaufort, which is exactly what you'd expect according to the genealogical record. Does that mean that Richard isn't Richard? Well, it could actually mean that there's simply a break in the line. And we know that forced paternities, i.e. illegitimacy, are not unknown. So if you look at published data using genealogical data, we can find that within just over 900 father and son pairs, we can account for 8 forced paternities. Again, you can build that into your calculations. There's the actual equations. Let's not worry about that. You then have to look at the number of generations over which these father and son pairs occur. And what that also means is that there is limited evidence against hypothesis 1. It doesn't disprove hypothesis 1, but there's limited evidence against it because it's not unknown to have a forced paternity, i.e. illegitimacy. So given the 19 generations, you actually have a fair chance of there being a forced paternity on the Y chromosome line. Now let's turn to the mitochondrial data. Well, that did match with Michael Ibsen completely, and it also matched with Wendy Duldig, apart from one mutation, which is not, again, unusual given the 19 generations. So because of that, you actually only need to use one of the skeletons. We use Michael Ibsen, and again, you have to first of all work out a mutation rate, which we've done over 19 generations, and then you have to work out what's the likelihood of that particular DNA type being shared randomly with a skeleton. And that's not particularly easy because there's not a lot to compare it with. It's actually an incredibly rare type of mitochondrial DNA. In fact, it's not observed at all amongst the standard library of English sequences of 1,823 sequences. If you move on, and therefore it gives you relatively strong, moderately strong evidence for it being Richard III. However, because we're being very conservative, if you widen the net to look not just at English but European mitochondrial DNA, what you can then calculate is the possibility of it falling into that wider group. Now, putting all of this together, the radiocarbon data has limited support for hypothesis 1. Age and sex, again, is in favor of hypothesis 1, but not particularly strong. Scoliosis has moderately strong evidence for hypothesis 1. The perimortal wombs, moderate support. The Y chromosome that doesn't match is evidence against hypothesis 1, but only limited evidence against. And the mitochondrial DNA is moderately strong. But what matters is that you put all of those things together. And this is where Bayesian statistics comes in its own, because we're not looking at any one of those things in isolation. What we're actually looking at is a skeleton having the combination of all of those things. And when you do that, all of the likelihood ratios are in this table. And when you combine them together, it shows that the support for hypothesis 1 i.e. it being that of Richard III, is extremely strong, with a likelihood ratio of 6.7 million. In other words, even having a kind of skeptical view, the probability of the skeleton one is not Richard is less than 1 in 100,000. To look at this another way, and again, this is where we have to talk about the starting position, the background probability. If we change that to 50-50, then the probability is much less than 1 in a million. So taking all of these assumptions into consideration, the underlying calculation here shows that the hypothesis one, that the skeleton is that of Richard III, is beyond reasonable doubt. And I guess what I'm saying here, I realize there's an awful lot of information here to take in, but the point I'm trying to make is that the identification process is rather separate from the archaeological process. And the notion that it was all about DNA is actually incorrect. As I have shown you, if you only looked at the DNA evidence in isolation, it would only have given limited support to this notion of it being Richard. What really makes it beyond reasonable doubt is the combination of the genetics evidence, the DNA evidence, together particularly with the scoliosis evidence and particularly with the battle wounds evidence. And it's looking at all of those things in combination that statistically makes it quite clearly, in our view, the skeleton of Richard III. And also, as I said, it's often stated that the DNA is the thing that proved it, but it's actually the combination, the genetics evidence only gives moderate support. And the non-genetic evidence is over 1,000 times stronger in combination than the genetic evidence alone. Okay. So what I also want to do is to leave you also with this, which is something I did at the time. And we didn't actually use in the combination, in the statistics, because we couldn't really think of a way of working it in. But what I also did is that because we kind of thought, well, what is the probability of somebody with the same mitochondrial DNA as Richard, i.e. a close relative of Richard, having also died at the Battle of Bosworth and having also been brought back to Leicester and having been buried in the Greyfriars Friary, i.e. have we mixed this skeleton up with another person who may have died at the Battle of Bosworth? And what you can't see on this diagram is that right over here, that's actually Richard over here. These are all the people that would have shared mitochondrial DNA with Richard. And I went through them all one by one and eliminated them, either because they either didn't die at Bosworth, they were known to have died before or after, have survived Bosworth, or are known to be buried somewhere else. And there are only two people on here whose burial is unaccounted for. One is Richard himself, and the other one is a distant cousin whose burial place is uncertain, but is probably buried on the Isle of Rhodes in the Mediterranean, where he was on crusade. Without doubt, we are convinced, and it's the statistics that really helped us to work out what the probability of this pile of bones was being Richard III. So the statistics and the maths were absolutely critical to the whole investigation. And I will leave that there. I'm sorry that some of this has been rushed. I'm sorry that there's been a lot of detail, but you'll have the slides. You can go back and look at the slides in leisure later on. But hopefully I've made the point that it was not one particular factor like the DNA that proved this was Richard, but it's the combination of this and how you use that evidence to work out probabilities of the skeleton being those of the mortal remains of Richard III. So it's just gone 7 o'clock. I've been talking about 5 or 10 minutes longer than I should have done. Hopefully you found that interesting and will still have time to ask questions. So thank you very much.